So hello everyone. So this is another question which I created myself to illustrate the phenomenon of how the inductance changes with the geometry. Okay. So let me just add a small bit to the question. Assume mu r equal to 1000. Okay. So let's look at the question. A wire of length 2 meters is wound on a square core of mean side 10 centimeters and square cross section of 1 centimeter by 1 centimeter. So there is a square core. So let me draw the square core. So this square core had, this is a square, so I have a mean side of 10 centimeters. So this is 10 centimeters. So what is the length of the core? So 10 plus 10 plus 10 plus 10 would be 40 centimeters or 0.4 meters. Then the cross section is 1 centimeter by 1 centimeter. So if I take the cross section, so it's a 1 centimeter by 1 centimeter. Now the number of turns are not given, but the total length of the wire is given, which is 2 meters. So for one cross section, I think the side is 1 centimeter by 1 centimeter. So total cross circumference or circumference of the core is of the cross section will be 4 centimeters. So out of the total length of 2 meters, so 2 meters divided by 4 centimeters, so I will be able to get the length. Okay, so that is 200 centimeters by 4 centimeters. So this will be 50. Okay. So the total number of turns will be 50 for the coil. Okay. So if I roughly draw the coil, so coil will cover the entire core and it will have about 50 turns, n equal to 50. What will what is the inductance? Okay. So I know the cross section area, I know the length of the core, I know the number of turns, so I can find the inductance. Okay. So what is the inductance? So inductance is nothing but n square mu naught mu r into area by L. So this is the formula for inductance. So we have derived many times. So n square. So that is 50 square into mu naught 4 pi into 10 power minus 7 into mu r, that is 1000 given in the question, into cross section area. Now cross section area is 1 centimeter square. So r, I will say 1 into 10 power minus 4 meter square. So whole of this divided by the total length of the core. So the length of the core is 0.4 meters. So this is the calculation that we need to do to find the inductance. So let's do that. Can we do some simplification? So here 0.4. So I'll just say here I put one more 0 into 10 and then I can remove this 0.4. So 4 I can cancel out and this 10,000 I can cancel out 10 power minus 4. So finally I have 50 square into 5 into 10 power minus 7. So let's do this with the calculator. So I'm getting the calculator. So 50 square. So 50 square multiplied by 5. So I get this value. And then this I have to multiply 10 power minus 7. So into 10 x to the power of y 7 into minus 7. So I'm getting this value. So if I want to convert into millihenries, so I get this value as 785. Okay, 0.785 millihenries. So this is my inductance. Okay. Now let's go back to the question. So up to here I solved it. What will be the inductance if the side is changed to 15 centimeters and the cross section to 2 centimeter by 2 centimeter square? So the same wire, okay, the same wire is now going for a different core, then how it will be? Okay. So if the side is changed to 15 centimeters, okay, so now I roughly draw the figure here. Now the side is 15 centimeters and the cross section area is 2 centimeters by 2 centimeters. So rest of the things is same. So here first of all I have to find the number of turns. Okay. So total length is 2 meters divided by the circumference of the cross section, that will be 2 centimeters into 4, that will be the circumference of a square, that will be 8 centimeters. So that will be 200 divided by 8 and this will be 25. Okay. So I have 25 turns. Okay. So immediately I notice that the inductance is going to reduce because 25 square will be coming. I just substitute directly into that. Mu naught mu r will be as it is. And now what about the area of cross section? Area of cross section is now 4 centimeter square. So 4 into 10 power minus 4 and then divided by the length. Now the total length is has increased, so inductance is going to reduce once again. Okay. So the total length is now 15 into 4, so that is 60 centimeters or zero point 0.6 meters. Okay. So let's substitute the numbers and then simplify this. So 25 square multiplied by 4 pi into 10 power minus 7 into 1000 into 4 into 10 power minus 4 all divided by 0.6. Okay. I think I'll right away do it in the calculator. So this 10 power, this 3 zeros I'll cancel out here. Still there will be 1, so I'll put a point here. So it will be zero point 0.4 to compensate for that. And in fact I can cancel out these 2 points, so I have 4 by 6. Okay, so now let's get the calculator. So we have 25 square multiplied by 4 multiplied by pi multiplied by 10 to the power of minus 7, okay, multiplied by 4 and divided by 6. So this is the final answer. So if I neglect, if I express the inductance in millihenries, so it will be 523 millihenries. So the inductance will be 0.523 millihenries. So what did we notice? So earlier the inductance was 0.785 millihenries. Now the inductance reduced to 0.523 millihenries just with the same wire, but because of the geometry is different. So if I look at the formula once again, so here you can see inductance is proportional to area. So the area is increasing, so inductance is supposed to increase. But then because the area is increasing, the length of the wire itself is 2 meters. So my N is reducing and this is having a higher effect. Another thing we noticed was the length is increasing. So because of the length is increasing, that will further reduce the inductance. So I hope this short uh, problem has given you some more understanding how the inductance varies with the geometry of the winding and the geometry of the core.